This video in the Pure Maths 1 course concerns transformation of functions and their graphs. Let's consider the function x squared minus 6x plus 8. This is a quadratic function, so its graph is a parabola, and as we can see by this red curve here, it's this parabola. It's in this orientation, as the coefficient of x squared is positive, so it's of the U shape. We can see it passes through the 8 on the y-axis, as f of x is 8 when x is 0. And if we factorise the quadratic, the factors would be x minus 2 times x minus 4, and so the curve passes through 2 and 4 on the x-axis. There are several transformations we can do on this function. For instance, if we were to do this, it moves up, the curve moves up, and if we do this, the curve moves down. Moving up and down is achieved by adding a value to the y-coordinate. So if I want to move up by 2, a factor of 2, each point moves 2 in the y direction, parallel to the y-axis, and so I add 2 to each y value, and that's achieved by adding 2 to the function. So here y equals f of x plus 2, or the function x squared minus 6x plus 8 plus 2. The more I add, the further we go in the y direction. If we subtract a number from the function, the curve moves down. We call this transformation a translation. So this, for instance, is a translation of factor 4. As here we have moved up 4, translation of factor 4 parallel to the y-axis. So we say what it is, a translation, by how much, a factor 4, and the direction, the parallel to the y-axis. Alternatively, we could translate parallel to the x-axis like this. This is a translation parallel to the x-axis of factor 5. We can see the value, this point here 2 has moved to this point here 7. The other intercept with the x-axis 4 has moved to 9. So the curve has been translated by a factor 5 parallel to the x-axis. Now this is actually achieved by subtracting 5 from x. We can see here when x is, we know the value of the function when x is 2 is 0, f of 2 is 0, so by subtracting 5 we have 7 minus 2 plus minus 2, 7 minus 5 is 2, so when x is 7, we have y equals f of 2, and so that is 0. So this is a translation of factor 5 parallel to the x-axis. Alternatively, if we added 5, like that, that is a translation of factor 5, factor minus 5 parallel to the x-axis. So in this case, by adding 5 to x, we go in the we are parallel to the x-axis in the negative direction. So we say that that is a translation of factor minus 5 parallel to the x-axis. If we subtract 5, we have a translation of factor -5. By subtracting 5 from x, we have a translation of factor +5 parallel to the x-axis. So the factor is in fact the opposite sign as the the value that we add. Another type of transformation is a stretch. Here is a stretch of factor 2 parallel to the y-axis. And we see what's happened here. The curve is has been stretched. So we can see any point. The minimum point here has been, which is has twice as far from the x-axis pulled down, and all points are pulled up. If we take this point here, stretch of factor 2 drags it or pulls it up twice as far away from the x-axis. If we do a stretch of factor 3, there it's now, that point has now been stretched 3 times as far from the x-axis in the y direction. So we call this transformation a stretch parallel to the y-axis of factor 3. The equation, because we are doubling the value of y at every point, the equation of the transformation is 2 times f of x. So we multiply the function by 2. 3 times gives you this function, and we have 3 times the function. If we have the transformation y equals 0.5 f of x, a half f of x, then we have squashed or compressed the curve, and each point is half as far from the x-axis as it was. So this point here has been transformed or translated, transformed to halfway, half as far from the x-axis. The y value here is about 4, it's now here about 2, and the equation is y equals a half f of x. You can also see the minimum point is about half as far from the x-axis as before. Notice that on a stretch, points that are on the x-axis itself stay where they are. They stay on the x-axis. If we multiply the x by 2, so we have f of 2x, we get this. F of 2x results in a compression parallel to the x-axis. So we would call this a stretch of factor a half parallel to the x-axis. We can see that the point 4, 0 has been transformed to 2, 0, and 2, 0 has been transformed to 1, 0. So the points on the x-axis are half as far away from the y-axis now. The point 0, 8 has remained where it is, so that doesn't change on a stretch parallel to the x-axis. To achieve an actual stretch of factor 2 would require a transformation of f of a half x. So f of a half x here, where you can see from the equation we're multiplying the value of x by a half, and that is a stretch of factor 2. 2 goes to 4, 4 goes to 8, as we can see. Every point on the curve is twice as far from the y-axis as the point on the original curve. So this point here is transformed to that point here twice as far from the x-axis, and so on. There's the minimum point. To summarise so far, then, f of x plus a, so adding a number to the function, that's a translation parallel to the y-axis of factor a. Those three things need to be written when you described a transformation. F of x plus a, like this, where you're adding a number to the x, is a translation parallel to the x-axis of factor minus a. So f of x minus a is a translation parallel to the x-axis of factor a. So the curve goes into the opposite direction to the sign of the factor. A f of x is a stretch parallel to the y-axis of factor a, and f of ax is a stretch parallel to the x-axis of factor 1 over a. So f of 2x then is a stretch of factor a half. If you want a stretch of factor 2, you need f of a half x. That will be a stretch of factor 2. Two more transformations you need to know are reflections. A reflection in the x-axis and a reflection in the y-axis. First of all, a reflection in the x-axis. Notice every point on the original graph has an associated point on the reflected graph, which is the same distance but on the other side of the x-axis. So the same distance from the x-axis but on the other side. We can see that the minimum point here is a maximum point on the reflected graph, and the values on the x-axis themselves, the points on the x-axis themselves, stay the same. What is happening here, of course, is every value of y is transformed to every value of every point. That y value is transferred to a point with the negative y value. So the point there goes down here. The point here goes down here. It has the same size of y value but negative, and so that is represented by the equation y equals minus f of x, because we are making the y value minus the value that it was. If it is negative, right here in the minimum point, it becomes a positive value, because a minus a negative is a positive. Here is the curve reflected in the y-axis. As we can see, every point has an associated point the same distance away from the y-axis as the original. So the minimum point is over here, the same distance from the y-axis. Any point that's on the y-axis, like 0,8, stays where it is. And what's happening here is the y value of a point on the reflected graph is the same as the y value of the negative x value. So when x is minus 3, we have the same value as when x is plus 3. So f of minus 3 is f of 3, which is the value here on the original graph. So the transformation, the graph of the transformation, is given by f of minus x. So we're making the x value negative. We negate the x value to give the y value. So then, to complete our summary, minus f of x is a reflection in the x-axis, and f of minus x is a reflection in the y-axis. For the reflections, when describing a reflection, there is only two things to say. it's a reflection, and the axis which it's reflected in. So let's now look at this problem here. Sketch f of x is x brackets x squared minus 1, and separately 2f of x, f of x minus 2, and f of minus x on the same axes. So we want to sketch the curve f of x equals x into x squared minus 1 3 times, and for each time we want to sketch these 3 curves on each separate axis, on each of these 3 axes. Now, what is the curve x brackets x squared minus 1? Well, this is a cubic curve. We could expand it by writing it x cubed minus x. We'll see if it's a cubic. Or we could factorise it. X squared minus 1 factorises into x minus 1, x plus 1. So this is a cubic which passes through the origin, and it also passes through the points 1, 0 and minus 1, 0. So it looks like this. And I could sketch that on each of the other 2 axes as well. Now first of all we want to sketch 2f of x. Now what transformation is this? Well, going back to the list, 2f of x we see is a multiple of f of x, is a stretch parallel to the y-axis of factor 2. A stretch leaves the points on the x-axis, stretch parallel to the y-axis, leaves these points here alone, that they won't change, and the rest would stretch up, so the maximum or minimum would be twice as far. And so this would look something like that. When you're asked to sketch these, you must indicate the points where the curve crosses the coordinate axes. Here it is 1, 0, well that's the origin, that's already specified by the axes, and minus 1. The second function we want to sketch is y equals f of x minus 2. If we go and look at our list of transformations again, f of x minus 2, well, f of x plus a is a translation parallel to the x-axis of factor minus a. So f of x minus 2 will be a translation parallel to the x-axis of factor plus 2. And so these points minus 1, 0 and 2 and 1 will be all translated by 2. And the curve is translated along by a factor 2, so we must indicate the points where it crosses the axes. Minus 1 goes to 1, 0 goes to 2, and 1 goes to 3. The equation of this new curve, well, just replace the x by x minus 2. F of x is x minus 1, x plus 1, so f of x minus 2, well, replacing x by x minus 2, we'll have x minus 2. X minus 2 minus 1 is x minus 3, and x minus 2 plus 1 is x minus 1. Now we should really also put in the point where the curve crosses the y-axis. You may need to do that if the question asks you. Well, that is of course where x is 0. So x is 0 is in fact f of minus 2, and substitute 0 here, we'll have minus 2 times minus 3 times minus 1, which is equal to minus 6. And so if the curve is extended down to where it crosses the y-axis, this here is minus 6. Lastly, we want to sketch f of minus x, and that, going back to our list, f of minus x here is a reflection in the y-axis, and so everything on the x on the right hand goes to the left, and on the left hand goes to the right. So the curve will look like that. Again, you need to put in the values where it crosses the x-axis, which haven't changed. In fact, minus 1, 0 and 1. Put 0 there if you wish. Now return to Study Smart. There will be another video showing a further example of this and some problems for you to practice.